gonna showcase the project CallGuard Sentinel. The aim of this project is to detect fraud calls. So while like if say a low tech savvy person is talking on phone and someone is trying to scam them, then we'll tell them ki, yeah, you are getting scammed. This was the aim, and then we have the basic analytics here, nothing too crazy here. Call history, everything is working here. Then the main USP of this project is to when I make a call. So say I dial a random number, okay? Now pretend that everything I speak from here now is coming from the other side. हेलो कैसे हो आप घर पे सब ठीक है अच्छा मेरा कल आना होगा तो आप प्लीज़ बता देना उन्हें कि मैं आ रहा हूँ कल एंड इंशाल्लाह मिलते हैं कल. So this was meant to be a normal call, and I'm speaking to a friend here, and like pretend ki, yeah. So this is not uh, like it warned me because it was an unknown number that was calling me, and it was not in my contact list. But when it made call over to the backend, then it realized that it was not like a scam call. And how this is happening, I'll go over in a second. Now let's make another call, and this time let's try to scam. Hello. Yeah, hello. Am I talking to Mr. Arshil here? Yeah, you just won 1 lakh rupees. Sir, I need your OTP in 10 minutes, or the shipment will be delayed and you won't be getting your money. So yeah, in 10 minutes I will need your OTP. So yeah, this was meant to be a scam call. It gave me warning on front end. This logic is purely like front end based to run quickly, and then we are doing a back end call later. So as you can see, yeah, this was a scam. And let's go over the architecture for a bit. As you can see that we have confidence score, a percentage of what's the likelihood of it being a scam, and the reason of why it's a scam. So if I go over to the tech stack now, the tech stack is quite simple. We are using like React for the front end. This front end is built on React. Then we are using a front end server because we had two teams that were working together, one on the front end and one on the ML side. So yeah, we have the React in front end. Then we are using Postgres as an as the database. After that, the backend server is using Fast API and also a bit of the front end server, the second backend that we made. Now, the main USP of this project is the architecture itself. So let's go over it in a bit. So what's happening is that first the audio getting ingested. This handles the chunking process because we didn't had CPaaS available and a bunch of permissions needed to do this right now. We couldn't make the backend process that was running later in the later stage entirely real time. But yeah, this audio ingestion unit is to divide the audio into chunks and then send it over to the next step. Next, we have two main unit. First is a word analyzer. Word analyzer will analyze the words obviously, and then we have an audio analyzer that will detect the raw, like take things from the raw audio. From the word analyzer, what we are doing is that we are transcribing using Whisper. We tried using TTS, normal TTS, but that didn't give like appropriate results. So we switched over to Whisper. We're using faster Whisper for this, and if I show you, yeah, it should be around here. Yeah, we're using faster Whisper for this because yeah, faster Whisper is obviously fast. And what we're doing is that we are extracting certain features from it. So this is handled by the text feature extractor. By the way, this entire project is on GitHub if you do want to explore it a bit. So this text extractor feature, this is the entire it's giving authority, urgency, threat, bait, language switching. These are the parameters that will be ranked based on the words, and these are like 0 to 1 parameters, float parameters. Then from the raw audio, I'm getting two different sets of things. First, the conversational, which will be turn taking. So if I'm a scammer, it's observed that I will tend to speak more than the victim I'm scamming. So this is handled by the entire audio and like the pipeline. And then we have the acoustic feature. So it's more likely that if I'm scamming someone, I'm sitting in call center, and if I'm really professional, and say if I'm asking calling from a bank, most likely I won't have a TV going on in the background. So based on these three, we are feeding it to a master model, which is over here. Wait, is it? Yeah, yeah, master, and by the master model, and we also have a like LLM verifier layer, just for a bit more magic and like to correct the result a bit more. So this was the architecture of the project. And yeah, so the range is that it gave us very good range, as you just saw that for the like for the fraud it gave us like 95, and for non-fraud it gave us like 0. So yeah, this was our project that won second prize in the Cyber Cup event. Hope you enjoyed it. If you have any questions, do let me know. Thank you.